Bismillahirrahmanirrahim. Today I'd like to talk about some postulates and theorems that we use in proving angle relationships, similar to what we had done before for segments. In fact, our starting point is going to be this particular table, for which I hope we are reasonably familiar now. Here we have properties of equality for real numbers, and you're, I'm sure, quite familiar with the addition, subtraction, multiplication, division property of equality for real numbers, the reflexive, symmetric, and transitive property of equality for real numbers, the substitution property of equality for real numbers, and the distributive property of equality for real numbers. To this we had added previously properties of congruent segments, the reflexive property of congruent segments, the symmetric property of congruent segments, and, of course, the transitive property of congruent segments. Today, we shall add to this particular list some properties for congruent angles, and these are all very similar to what we had seen before for congruent segments. That is, we have a reflexive, symmetric, and a transitive property of congruent angles. So we have properties of congruent angle. So we have, again, reflexive property of congruent angles, symmetric property of congruent angles, and transitive property of congruent angles. Specifically, the reflexive property of congruent angles, the reflexive property of congruent angles, the reflexive property of congruent angles states that an angle is congruent to itself. So the reflexive property of congruent angle states that the angle is congruent to itself. The symmetric property of congruent angle states that if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. And finally, the transitive property of congruent angle states that if angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then angle 1 is congruent to angle 3. So it's very similar to properties of congruent segments. So we have properties of congruent segments, we have properties of congruent angles. Again, if you recall, in the transitive property of congruent segments and angles, we have something that acts as a bridge, or that's common to two statements. In this case here, angle 2 is common to these both statements, which acts as a bridge for the other two angles. So we're always looking for some commonalities between two statements, so that we can combine those two statements using the transitive property of congruent segments and transitive property of congruent angles. So these we have to know really, really well: the properties of equality for real numbers and properties of congruent segments, and to this we added today properties of congruent angles. Now, there are many theorems and properties for angles and angle relationships. So today we're mostly going to talk about these, and next time we should use these to formulate some proofs. And these are, in my mind, they're quite fun and exciting. And the first thing, however, is that we have to know these preliminary properties and theorems about angles. So that's what we're going to do first. So today, as I stated, we shall mostly talk about some important properties and postulates and theorems about angle relationships. And next time, we shall develop and use these in some proofs of some problems. So first, recall the segment addition postulate it basically stated that you can take two baby segments and add them together to give a longer, bigger segment. And specifically, the segment addition postulate said if A, B, and C are collinear, if you have 3 points that are collinear, then point B is between AC if and only if AB and BC, if AB plus BC will give you AC. So that's the segment addition postulate. In other words, two baby segments will add up to give one big segment. We have a similar postulate and as it relates to angles. Basically, this postulate states that two baby angles add up to give you a one big angle here. So we have angle ABC, this big angle over here. That's angle ABC. And then inside that angle we have a ray over here, ray BD, which is creating two additional angles. This angle here, let's go one angle here, and that's number 2. So we have two small angles. So the angle addition postulate states specifically that D, this point D, is in the interior of an angle. If you recall, an angle has an interior and an exterior. So a point is in the interior of an angle. Point D is in the interior of an angle, angle ABC. So D is in the interior of ABC. That's the big angle over here. So point D is in the interior of ABC. If and only if, this is a biconditional statement, that means the original statement and its converse are true. So D is in the interior of angle ABC if and only if measure of angle ABD, that's ABD, okay, plus the measure of angle DBC, that's this angle over here, will add up to give you the measure of angle ABC, that's the big angle. Now, this is very similar to the segment addition postulate, because then we said B is between A and B if and only if. So that's B is between A and C, so B is between A and C if and only if. Here we're saying point D is in the interior of this angle ABC if and only if. So these two postulates are very similar. Again, the angle addition postulate states that any point D, a point D is in the interior of an angle, in this case angle ABC, if and only if the two baby angles add up to give you the big angle, the two baby angles created by the point D. If and only if ABD, that's the red angle over here, plus the measure of angle DBC, that's this angle, the blue angle over here. If the red angle and the blue angle give you the big angle, is this angle here over here, ABC. So another way of saying, more affectionate way of saying the angle addition postulate is that two baby angles give one big angle here. So thus far we have learned the congruent angle properties, the reflexive, symmetric, transitive properties of congruent angles, and then to this we have added the angle addition postulate, which is very similar to segment addition postulate. So we have segment addition postulate and we have the angle addition postulate. Okay, so here is a theorem. Now this is a theorem that is, we can actually prove this to be the true. And you can give theorems some affectionate names, so to speak. You can give them any name you want them, so that you can, to help you jog memory of the theorem. You know, you can call it whatever you like. I actually call this theorem the linear pair theorem. Your textbook actually calls this theorem the supplementary angle theorem or something like that. But that's not as intuitive to me as a linear pair theorem. So it doesn't matter what you really call it, hopefully anything to help you jog your memories. But what you really need to remember, actually, is the theorem itself. In this case, the theorem states that if two angles form a linear pair, then they are supplementary. If two angles form a linear pair, then they are supplementary. If you recall, two angles are a linear pair if their non-adjacent side, if their non-shared side are opposite rays. So between angle 1 and 2, this is a common side, that's the shared side, okay? And these are the non-shared side, that's the non-shared side over here. So the non-shared side, the non-common side are opposite rays. If they're opposite rays, that means they make 180 degrees. That's the definition of opposite rays. So because that's 180 degrees, then angle 1 and angle 2 must add up to 180, and that's the definition of supplementary angles. Now this is a pretty intuitive theorem, but you kind of need to know it verbatim as it is stated. That is, if two angles form a linear pair, darn it, they are supplementary. If two angles form a linear pair, then they are supplementary. That seems pretty easy and logical if two angles form a linear pair. But you have to memorize these. So the objective today is again to introduce you to all of these postulates and properties, postulates and theorems, so you can memorize them, so the next time inshallah we can use them in proofs, and that's where the real fun is, I think, inshallah. So this is one of the theorems that we have to memorize. The next theorem is very similar to the linear pair theorem, and it states that if the non-common sides, again, so just like over here, because a linear pair, there's the common side and there's a non-common side. So if two angles of a linear pair, well, in a linear pair you have a non-common sides over here, right? And there's a common side. So in the same way, if two non-common sides of two adjacent angles form a right angle, then the angles are complementary. See here, the two non shared side, the non-common sides, form 180 degrees or linear pair. Here, the two non-common sides form 90 degrees, so they're complementary. So these two theorems are very similar in the thought processes. So the linear pair theorem states that if two angles form a linear pair, then they are supplementary. The complementary adjacent angle theorem, that's what I call this, complementary adjacent angle theorem, you can call the linear pair theorem a supplementary adjacent angle theorem if you wanted to. If the non-common sides, that's this side, if the non-common sides of two adjacent angles form a right angle, that is, they make a right angle, then the angles are complementary. Then angle 1 and angle 2 are complementary. So if you notice here, angle 1 and angle 2, they have a shared side, that's the common side, and there's two non-common sides. If the two non-common sides of these adjacent angles, they make a right angle, then angle 1 and angle 2 are complementary. Okay, you have to memorize this also. So let's read these two theorems again together. The first theorem, the linear pair theorem, states if two angles form a linear pair, then they are supplementary. And then the complementary adjacent angle theorem states if the non-common sides of two adjacent angles, form a right angle, then the angles are complementary. Okay? Also very intuitive. If the non-common sides of two adjacent angles form a right angle, then they are complementary. So these are two theorems that we also have to memorize. Okay, here we go. We have two more theorems to go, and that for today, inshallah. Here it is. This one, I call it the supplements to the same angle theorem. Supplements to the same angle theorem. Alright, now watch this. If two angles are supplementary, or they're supplementary, right? If two angles are supplementary to the same angle, then they are congruent. So it's a very beautiful theorem, this one. We shall prove this, inshallah, next time. If two angles are supplementary to the same angle, then they are congruent. Well, let's take an example. Let's say that this is 150 degrees over here, okay? Angle 1 is 150 degrees. I'm just making that up. And if angle 1 and angle 2 are supplementary, if they happen to be supplementary, then this is like 30 degrees, right? 150 plus 30 is 80 degrees. Now, if 3 and 1 are supplementary, if 1 and 3 are supplementary, then 30 also has to be 30 degrees, right? So in this case, you can see angle 2 is supplementary to angle 1, and angle 3 is supplementary to angle 1. So if two angles are supplementary to the same angle, then they are congruent. If this is supplementary this, if this is supplementary this, then obviously 2 and 3 are going to be congruent. But this is the theorem that you have to memorize, okay? So this theorem states again that if two angles are supplementary to the same angle, then they are congruent. I call it the supplements to the same angle. 2 supplement to 1, 3 supplement to 1. If two angles are supplementary to the same angle, then they are congruent. So supplements to the same angle theorem. So again, this theorem states that if two angles are supplementary to the same angle, then they are congruent. All right. Our last theorem for the day is very similar. This one's called complements to the same angle theorem. Complements to the same angle theorem. This one states, if two angles are complementary to the same angle, then they are congruent. If two angles are complementary to the same angle, then they are congruent. All right, so let's say here's angle 1 and angle 2. Let's say this angle is 60 degrees. Angle 1 is 60 degrees, okay? So let's call this one, angle 1 is 60 degrees. Now, if angle 2 is complementary to angle 1, angle 2 has to be 30 degrees. And if angle 3 is complementary to angle 1, it also has to be 30 degrees. Now, you can see this angle 2 is complementary to angle 1, angle 3 is complementary to angle 1, and therefore angle 2 and angle 3 are congruent. So if two angles, in this case angle 2 and angle 3, are complementary to the same angle, in this case angle 1, then these two angles, angle 2 and 3, are congruent. So these are some beautiful theorems that we shall prove inshallah next time. Okay, so complements to the same angle theorem. If two angles are complementary to the same angle, then they are congruent. Okay, so before we finish, let's just review what we have learned. I shared with you today first some properties of congruent angles, the reflexive, symmetric, and transitive property of congruent angles. The reflexive property of congruent angles, an angle is congruent to itself. The symmetric property of congruent angles, if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. And transitive property of congruent angles states that if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, okay, so before we finish, let's just review what we have learned. Today I share with you properties of congruent angles, the reflexive, symmetric, and transitive property of congruent angles. Then I shared with you the angle addition postulate, which was similar to the segment addition postulate, where two baby segments give you one bigger segment. Here, two baby angles give you one bigger angle. The angle addition postulate specifically states that an angle that at point D is in the interior of angle ABC if and only if the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. That is, the two angles, when they add up together, will give you the one big angle if and only if this point D is in the interior. So we learned this angle addition postulate. Two baby angles give one big angle. And then we learned 4 theorems today. These are theorems that we can prove, inshallah. First is the linear pair theorem. This theorem states that if two angles form a linear pair, then they are supplementary. Angle 1 and angle 2 here form a linear pair because their non-adjacent side, the non-shared side, are opposite rays. That's what it means to be a linear pair. That the non-shared side is our opposite rays. So if two angles form a linear pair, then they are supplementary. Angle 1 and angle 2 form a linear pair, therefore they are supplementary. This is very intuitive, and you'll wonder how this will be useful, and you'll see how this will be very, very useful in the future. And then we learned the complementary adjacent angle theorem, and this is very similar to this one. That is, if the non-common sides, if the non-adjacent sides if the non-shared side, if the non-common sides of two adjacent angles form a right angle, and this is the symbol for right angle, then the angles are complementary. If the non-common sides, as this side and this side, of two adjacent angles form a right angle, then the angles are complementary. Now, I'm suggesting to you, you have to really memorize this. You have to be able to articulate, enunciate these theorems and postulates and properties. You have to be able to say them. Unless you're able to reiterate and recite these from your memory, you don't quite know them as well as we would like you to know. Nevertheless, if the non-common sides of two adjacent angles form a right angle, then the angles are complementary. And finally, there's 2 more theorems, supplementary to the same angle theorem. If two angles are supplementary to the same angle, then they are congruent. Here, angle 2 is supplementary to angle 1, angle 3 is supplementary to angle 1. So if these two angles are supplementary to the same angle, then these two angles, the latter ones, 2 and 3, are congruent. So if two angles are supplementary to the same angle, then they are congruent. And finally, if two angles are complementary to the same angle, then they are congruent. Complements to the same angle theorem. 2 is complementary to 1, 3 is complementary to 1, therefore angle 2 and 3 are congruent. If two angles are complementary to the same angle, then they are congruent. We shall build on this next time. Until then, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alamin. Assalamu alaikum.